Okay, moving on to section 7.6. We are going to be solving rational equations. A rational equation is just an equation that contains a rational expression, right? Meaning fractions. Okay, so anytime your equations have fractions in them, you can consider them rational equations. And so how do you solve a rational equation? Well, you have these 5 steps here. And before we go through the process here to solve this equation, this will be our first example. Let me note why this whole chapter, this chapter 7, is pretty difficult. For one thing, you'll notice that a lot of these steps look very similar to ones we've already done in the previous sections, in 7.5 and 7.4. Right? We had to find the LCD in those sections as well. And so we're doing it here. And so it's very easy to get all these procedures, right, mixed up. So it really you just have to go through this process for these problems and be careful you don't get confused with other problems where you're just adding or subtracting fractions, right? Or if you're simplifying a compound or complex fraction. So that's not what we're doing here. We're solving rational equations. Okay, so here's our example, and let me just write it down again. 2 minus 8 over x equals 6. So this is an equation, and we want to solve for x. So step 1, factor the denominators completely and find the restricted values. So luckily, there's really not much to factor here because these are all over 1, and so there's only one denominator, and that's just x. So the LCD, of course, is just x. So what are the restricted values? Well, 1 does not equal 0, but if x equals 0, that would be a restricted value. So this is a restricted value. Okay. Right. Step 2, find the LCD. Well, actually, we already did that. The LCD, of course, is just x. Okay. So I did this backwards, right? Step 1 is to find the restricted values. Step 2 is to find the LCD. And so we did that already. Step 3, multiply both sides of the equation. So this will be my step 3 here. And let me just copy down the equation one more time. 2 minus 8 over x equals 6. Right. And we don't need the 1s here. I just did that, because the LCD couldn't multiply by 1. 1 times x, of course, is just x. Okay, so step 3, multiply both sides of the equation by the LCD. In this case, we're multiplying both sides by x. Okay. Right. So we're multiplying by x on the left and x on the right. Now be careful, this is x over 1. We're not multiplying x over x. We're not doing top and bottom here. We're multiplying both sides only in the numerator. Right? So, yep, I mean, if it helps, this is still 2 over 1, 6 over 1, but you're not multiplying top and bottom by x. You're multiplying left and right by x. Okay. So, what happens then? Well, now we have to multiply all this out, right? So on the left, we get x times 2, or 2 times x, divided by 1, right? Minus x times 8, or 8 times x, divided by 1 times x, which is x. And then on the right, we get 6 times x in the numerator, 1 times 1 in the denominator. 1 times 1 is 1. And, well, notice that x divided by x here is 1. We can cancel the x's. And if we cancel the x's, we're left with 2x minus 8 equals 6x. So you see what we did here in step 3. In step 3, we multiplied both sides by the LCD, and then we just kind of simplified a little bit. And what you end up with at this point is an equation. And notice there's no more fractions. So the whole point for step 3 here is get rid of the fractions, or get rid of the denominators, right, other than the 1. So now in step 4, we just solve this equation. And this is a pretty straightforward equation. You can practically do this in your sleep. So I'll give you sort of a few minutes to think about how to solve this, but this should be fairly routine at this point. Right. So I'm going to actually subtract the 2x from both sides, and that's going to leave you with negative 8 on the left, and 6x minus 2x is 4x. Now I can divide by 4, and negative 8 divided by 4 is negative 2. 4 divided by 4 is 1. So we get x equals negative 2. And that's our solution. We're done. Step 5, check the solution in the original equation. So we'll do that in a second, right? The main reason for doing that, though, is to make sure that we didn't get the restricted value. The restricted value was 0. If we got x equals 0 as an answer here, we would have to eliminate that. We would have to cross it out. That cannot be an answer because it's a restricted value. Now that didn't happen here, right? Negative 2 is not 0, so that was not an issue. Okay, so in step 5, we're really just checking that we did all this correctly because it's very easy to make a mistake. And so I think we'll just check. The original equation was 2 minus 8 over x equals 6. And, well, we got an answer of negative 2 for x. So if I replace x with negative 2, is this correct? So notice, when you're subtracting a negative, you're really adding a positive. So this is plus 8 over 2. And 8 over 2 is just 4. 8 divided by 2 is 4. And 2 plus 4 is 6, right? So 6 equals 6. That's pretty convincing, right? That convinces me that x equals negative 2 is indeed correct. So we solved the equation. We got our answer. We checked it. It works. Let's move on to the next problem. Okay, so the next problem, this one won't be quite as simple, but it's the same idea, right? We want to solve, it says solve here, we want to solve the equation 1 over x plus 3 plus 6 over x squared minus 9 equals 1, which of course is just 1 over 1. Right? All right, so let's see, do you remember the first step? First step is to find the restricted values. And to do that, we probably need to factor this denominator here, which we've done many times already. I hope you can handle this. A squared minus b squared is a minus b times a plus b. In this case, x minus 3 times x plus 3. Okay, so yeah, we need the restricted values. So the restricted values, well, we have an x plus 3 in the denominator, so that would give us x equals negative 3. So hopefully we won't get that as our answer. We also have an x minus 3 in the denominator, so when that's equal to 0, we get x equals positive 3. So we get two restricted values, right? We get negative 3 and positive 3. Okay. Step 2, find the LCD. So notice that we have three denominators. We have the 1, we have the x plus 3, and we have the x minus 3 times x plus 3. Plus 3. So our LCD has to include all of these. So it has to include the 1, which, well, you can write the 1, but it's just 1, not necessary. We need the x minus 3, and we also need the x plus 3. Okay, so that's our LCD, x minus 3 times x plus 3. And you'll notice that this is already the LCD, so we don't have to do anything with that, right? All right, now we get back to step 3. So step 3, this is where it gets tricky. So let's do it slowly here. Let me just write down what we have so far. 1 over 1, right? And you remember what step 3 is? Well, what do we do with the LCD here, right? We're not doing top and bottom. We're doing left and right. So, oops, didn't mean to cross out the x here. Left, we're going to multiply by x minus 3 times x plus 3. And on the right, we multiply by the same thing, x minus 3 times x plus 3. Right, over 1. Right, we're not multiplying the denominator by the same thing. We're just multiplying left and right by the same thing. the LCD. Okay, now what comes next? Well, here's the tricky part. This is a sum, so we actually have to distribute this. So we're going to get 1 times x minus 3 times x plus 3 all over 1 times x plus 3, which is just x plus 3, right? Plus, now we have this fraction. Well, we have 6 times x minus 3 times x plus 3 divided by 1 times the same thing, x minus 3 times x plus 3. Okay. And what do we do on the right? On the right side we have 1, we don't need the 1, times x minus 3 times x plus 3. All divided by 1 times 1, which is 1. Again, we don't need that, but okay, fair enough. Okay, so yeah, after step 3, you end up with this horrible mess. You know, that can't be helped. However, notice that a lot of things go away here. We have x plus 3 divided by x plus 3. That's just 1. These cancel. And in the second fraction, we have x minus 3 divided by x minus 3. They cancel. And the x plus 3 over x plus 3, that also goes away. And on the right, nothing cancels, but that's okay because the denominator is already just 1. So we canceled all the denominators, right? That's our goal in step 3. Even though you get this horrible mess, all the denominators should go away, right? So everything is divided by 1, so we don't need the 1. What do we have left? We have the x minus 3. We don't need parentheses, but I'll leave them there for now. Plus 6, right? Everything else is gone. And that equals, well, x minus 3 times x plus 3. Right? Yes, divided by 1, but right. The whole point is to get rid of the fractions, right? So now we're on to step 4. Step 4 is to solve this equation. And this is a little more difficult than the one we did last time in the first example. So we're going to need a little bit of space here. So what do we do on the left here? X minus 3 plus 6. Notice I used parentheses just to group them together, but you're still doing x minus 3 plus 6. So you're still doing the same order here. So we didn't really need the parentheses here. X minus 3 plus 6, well, negative 3 plus 6 is 3, so this is just x plus 3 on the left. Now what about the right? For the right, we have to FOIL. Right? Multiply this out using FOIL. X times x is x squared. Then we have plus 3x. And we have minus 3x. And then we have negative 3 times 3, which is negative 9. And yep, 3x minus 3x is 0. So all we have on the right here is x squared minus 9. Okay. So this is going to be a quadratic equation, right? We can't get rid of the x squared here. So actually what I'm going to do is just switch sides. I like the x squared on the left and x plus 3 on the right. But because it's x squared, because it's quadratic, we have to get 0 on the right. We have to subtract x, not 3. Well, we're going to subtract 3, but not yet. Let's do the x first. Subtract x from both sides, right? And then subtract the 3 from both sides, right? Leaving you with, well, x minus x is 0, 3 minus 3 is 0, so the right side is 0, not 6, but 0, right? And on the left side, we have x squared minus x, and then minus 9 minus 3 is minus 12, right? Negative 9 minus 3 is negative 12, right? So now we have this quadratic equation, and notice we put this in standard form. That's the only way we know how to solve these, is to write it in standard form first. And so we did that. Okay, so the only way we know how to solve these at this point is if we can factor. Can we factor the left side? Sure. What two numbers multiply to negative 12 and add to negative 1? I mean, write them out if you have to, right? You can do 6 and 2, 12 and 1, but I think it's going to be 3 and 4. But negative 3 times negative 4 would be positive 12, so one of these has to be a positive. If we want them to add to a negative 1, we make the bigger number negative. So this will be x plus 3 times x minus 4. All right, and that's a little messy, so let me clean that up a bit. X plus 3 times x minus 4 equals 0. Okay, now we're almost done. We just set each factor equal to 0, right? If x plus 3 equals 0, then we can take away the 3 from both sides. That gives us x equals negative 3. Likewise, if x minus 4 equals 0, the opposite of subtracting 4 is adding 4, so that gives you x equals positive 4. And that should do it, right? That should solve the original equation, x equals negative 3 and x equals 4. So let me scroll back up a little bit. Where was the original problem? The original problem was way over here. So remember our two answers we got, well, I forgot already, negative 3 and positive 4, right? So x should be negative 3 or positive 4, right? Those are our solutions. So step 5, right? Remember, step 5 is to check, and we can plug them back in the original equation. We can plug it in this equation, the original equation, see what we get. But notice that, let's go back to step 1. Step 1 was to find the restricted values. The restricted values were negative 3 and positive 3. Well, look at that. We got negative 3 as our answer. Negative 3 cannot be an answer. It's a restricted value. Restricted means not allowed, right? Negative 3 is not allowed as our answer. So right away, we can cross that off the list. It's not a solution. Now, if you're wondering, well, why did we get that as a solution way down here? We got negative 3 as a solution. The answer comes in the fact that we multiplied by x plus 3. And if x is negative 3, right, then negative 3 plus 3 is 0. We multiplied by 0. And when you multiplied by 0, we effectively cancel the zeros, right? So that's what could go wrong here. This is why the first step is very important, that you find the restricted value, because if you leave negative 3 as a solution, it's actually wrong. You can check. It doesn't work, right? On the other hand, x equals 4 is a perfectly good solution. You can check. In fact, I guess we'll do that here. Let's check. So if we replace all the x's with 4, we get what? 1 over 4 plus 3 plus 6 over 4 squared minus 9. Does that equal 1? Right, and that's a 4. Sorry about that. Yeah, this is actually not that pleasant to check. We get 1 over 7 plus 6 over 16 minus 9. Actually 16 minus 9 is 7, right? Oh, this isn't that bad. This should be obvious, right? 1 over 7 plus 6 over 7. So that's just 1 plus 6 is 7. 7 over 7 is indeed 1. So yeah, that works. So x equals 4 is correct. But x equals negative 3 was not. So our final answer, x equals 4, is our solution, and our only solution. Right. So yes, originally we did get negative 3 as one of the options for a solution, but because it was a restricted value, we actually had to cross that off the list. It's not a solution. It's what's called, you can call it a fake solution, a phony solution. In math, we call this an extraneous solution. It's an extraneous solution. It's not really a solution. It's like a phantom solution. It's not really there. Okay? So either way, extraneous solution, phantom solution, it's not a solution. The only actual solution is x equals positive 4. So I hope that helps. Okay, on to the next example. And I think this is probably one of the more difficult ones, but if you can handle this, you should be able to handle any. So we want to solve 6 over x plus 3 plus 5 over x plus 4 equals 12x plus 31 over x squared plus 7x plus 12. And I should probably just copy that down here. 6 over x plus 3 plus 5 over x plus 4 equals 12x plus 31, and then over x squared plus 7x plus 12. I think while we're at it, why don't we just factor that? What two numbers multiply to 12 and add to 7? Okay, so it's not 1 times 12. 1 plus 12 is 13. It's not 2 and 6. 2 plus 6 is 8. 3 times 4 is 12. 3 plus 4 is 7. So x plus 3, x plus 4. Okay. So yeah, it helps to factor everything pretty quickly. So step 1, remember, factor all the denominators. Well, we did that. And then find the restricted values. So what are the restricted values? Well, anything that makes the denominators 0. So obviously, x plus 3 cannot be 0. So if x plus 3 equals 0, we get negative 3. And if x plus 4 equals 0, we get negative 4. So both negative 3 and negative 4, make sure they're negative, are restricted values. 2, find the LCD. Well, we need to include all the factors. The factors, there's only two unique factors, right? Two distinct factors, x plus 3 and x plus 4. So that's our LCD, right? So in step 3, okay, rather than do it vertically here, well, no, I guess I have to. Okay, so let me, oh gosh. All right, I'm going to have to copy this down again here. So 6 over x plus 3 plus 5 over x plus 4 equals 12x plus 31 all over x plus 3 times x plus 4. Okay. All right. Why did I have to copy it down? Because let's look at step 3. Multiply both sides by the LCD. The LCD we just found in step 2. That's this here, right? So multiply the left side by the LCD, x plus 3, x plus 4, and the right side. Remember, not top and bottom. So this is why I had to write it over again. I had no space over here to write the LCD. In fact, I barely have enough space now. So x plus 3 times x plus 4, right? So what do we do with that, right? Oh, yeah, this is over 1, right? Not top and bottom, but left and right. So now we're just going to multiply all this out. So we multiply 6 times x plus 3 times x plus 4 all over 1 times x plus 3. So you can see what's going to happen. We're going to cancel the x plus 3's. Plus, because this is a plus here, now we multiply this 5 times all of this, right? X plus 3, x plus 4. But this time we're dividing by 1 times x plus 4. And of course, the x plus 4's will cancel here. On the right, so we have 12x plus 31 times x plus 3 times x plus 4. Right? So notice there's nothing to distribute here. This is only one term. Divided by 1 times x plus 3 times x plus 4. That's a 4. Okay. Well, so again, we get a big mess here, but if we look carefully, we see that this denominator, x plus 3, cancels with this numerator, x plus 3. In the middle term here, this term here, we have an x plus 4 on the top and an x plus 4 on the bottom. Those cancel. And on the right, notice that they both cancel. The x plus 3 cancels with this x plus 3, and then this x plus 4 cancels with this x plus 4. And so that just leaves you with the 12x plus 31. So let's write what we have remaining here. We still have the 6. That didn't go away. So 6 times x plus 4 for the first term, plus, and then 5 times x plus 3. Obviously, we're going to have to expand these out, but let's do that on the next step. Equals 12x plus 31. Okay. No parentheses needed here because we got rid of everything else, right? Okay, now distribute the 6. So 6 times x plus 6 times 4 is 24. Plus 5 times x, 5 times x, plus 5 times 3. 5 times 3 is 15. and that equals 12x plus 31. Okay. So again, notice at this stage here, we got rid of all the fractions. Right, the denominators are 1. And now we just solve this equation. Right? And in fact, there's no x squared. It's not even a quadratic equation. So this is actually just a linear equation. We have 6x plus 5x, combining like terms, that's 11x. And then 24 plus 15, 39, I think. Yep, 39. And on the right, we just have 12x plus 31. And let me just switch side. Well, we don't have to, but I prefer to have this on the left and then this on the right. Right. So reason for that is I can subtract the 11x from both sides, leaving us with, well, 12x minus 11x is 1x. Right? And I can subtract the 31 from both sides. Right? So that leaves 0 here. And then on the right side, 11x minus 11x is 0. 39 minus 31 is 8. So we have 1x plus 0, which is just x, equals 0 plus 8 is 8. Well, that better be the solution, right? I think that's the answer. Of course, we should check. So let's go back way up here, right? So this was our original question, and we got an answer, hopefully, of x equals 8, question mark. First of all, check that these are not restricted values. The restricted values were -3 and -4, and 8 is not among those restricted values. So we didn't get a restricted value in this case. Okay, so that's a good sign. That's a good indication that this probably is the correct answer. The other thing, of course, you should do is check by plugging in 8 everywhere you see an x. And that, well, I guess let's do that here. So 6 over 8 plus 3 plus 5 over 8 plus 4. Does that really equal 12 times 8 plus 31 all over 8 squared plus 7 times 8 plus 12? Now, this one's not going to be pleasant. We have 6 over 11 plus 5 over 12. Does that equal, calculator time, 12 times 8 is 96. Yep. And 96 plus 31 is 127. Oops, sorry, 127 over, oh boy, so 8 squared I know is 64. So 64 plus 7 times 8 is 56, plus 12, which is 132. So the denominator here, oh, I did it again, hang on. This should be 132. Wow. So is 6 over 11 plus 5 over 12 equal to 132? I mean, that's a good question. I don't know the answer to that offhand. So there's two ways of doing this. You can just add these two fractions, get a common denominator. It's 11 times 12. But you'll notice 11 times 12 is 132. So if we multiply both sides by 132, this might be a quick way of doing this. 132 and then 132 over 1, right? So on the left, hang on, let me split this up here. We get 132 divided by 11 is 12, so 12 times 6 plus 132 times 5, I can't do that in my head, but 132 divided by 12 is 11, so that's 11 times 5. And on the right, when you cancel the 132s, this should equal 127. Does it? So 12 times 6 is 72, 11 times 5 is 55. Oops, that's a 5. Does that equal 127? 72 plus 55. Well, my calculator says 127, and that is certainly equal to 127. So now we can erase the question mark. Now we should be absolutely certain that x equals 8 is the correct solution. And so that's the answer. Well, I hope this helps. Again, this was not an easy one. This involved a lot of algebra here, but, you know, some of the questions could be as bad as this. This is sort of maybe a worst case scenario. They're not going to get much harder than this. In fact, they're not going to get any harder than this. So I hope that helps. Okay, actually, I feel like we should do one more problem because this one is a little different from the ones we've been doing. So this is another example. This is example 18 in my notes. Don't worry about that. So here we have an equation, 1 over c, see if I can write this down, 1 over c equals 1 over a plus 1 over b. So this is also a rational equation, but we're not solving for x here. We're solving for b. We're solving for this b over here, right? So this is going to be a little bit different, but you can think of it as sort of doing it the same way, right? We don't know what a, b, and c are, but they're just letters, right? So the first step is to find the restricted values. Obviously, we know that a cannot be 0, or sorry, a equals 0, b equals 0, c equals 0 are the restricted values because we want to make sure the denominator is not going to be 0. Okay. Step 2 is to find the LCD. So we factor all the denominators. Luckily, there's nothing to factor here. Right? We just have c times a times b, or a times b times c. Doesn't matter the order. So that's our LCD. Right? Okay. Step 3. Now this is where it always gets dicey. So let me just copy this down again. 1 over c equals 1 over a plus 1 over b. That was the original equation. Oops, not b over a, 1 over b. 1 over b. Right? So, you know why I'm doing this. We're going to multiply both sides by the LCD. The LCD is ABC, or a times b times c. But not top and bottom, right? Left and right. Right? Only in the numerators. So what do we get on the left here? On the left, we get this fraction here. We get a times b times c times 1 divided by 1 times c. And on the right, now we have to distribute this. We get 1 times a times b times c over a times 1 plus 1 times a times b times c over b times 1. Again, a big mess, not easy to deal with. However, you'll notice that you're just multiplying here. C over c, this is a common factor. We can cancel it. Here, we have a over a. That cancels. And in the last term, we have b over b. That cancels. So what are we left over? What's left over here? We have a times b equals b times c plus a times c. And again, we got rid of the fractions. That's the whole goal of step 3 here. If you remember step 3, multiply both sides by the LCD, only in the numerator, and then we just have to simplify all this. And when we simplify, yep, we got rid of the fractions. At least for now. At least for now. So what are we trying to do now? We're trying to solve for b. Now, this is where it gets a little tricky as well. You might say, well, if I'm solving for b, just divide by a. Here's the issue with that, though. There's also a b over here. So if you have b on both sides, that's not solving for b. Right? If you have an equation x equals 2x plus 3, that's not solve for x. You didn't solve for x, right? Because you have x on both sides. Right? So what would you do? You would subtract the 2x from both sides. But over here, we're going to have to subtract, let's see, this term from both sides. Minus bc minus bc. So on the left, we get ab minus bc equals, right, this is 0 now, bc minus bc is 0, but we still have a times c on the left, right? So by subtracting, we managed to pull all the b's on the left. Unfortunately, we still have the a and the c here, right? And this is where it gets, well, it's already complicated, but this is also the tricky part because a lot of people get stuck here and say, well, right, I can't add the bc to both sides because that brings the b over. I can't subtract ab from both sides because that brings the b over again. So I did all this work to get all the b's on the left. So adding or subtracting now is not the way to go. The way to go is this. Look at what we have in both of these terms. They both have a common factor. They both share a b. That b is our GCF. You can think of the GCF as just b. So what do you do with factors? You factor them out. Factor out the b. So what does it multiply? It multiplies a minus c, right? So if we multiply this out, we would get b times a minus b times c. Forgive me for the fact that b times a is the same as a times b, so it's really just the same thing, right? But here, it's okay to switch the order, right? B times a times b, 3 times 5, 5 times 3, same thing. And then this is equal to a times c, right? So I didn't change anything on the right yet. So hang on. I'm just going to copy this down here. B times a minus c is equal to a times c. So that's what we have here. That's what we have so far, right? Okay. So we're not quite done yet because we want to solve for b, right? We're solving for b. And luckily, there's only one more thing we have to do. What's the opposite of multiplying b times a minus c? The opposite of multiplying by a minus c is dividing by a minus c. So essentially, we just want to cancel the a minus c's here, right? And so now, all that's left on the left, all that remains on the left, I should say, is the b. And on the right, we have a times c on the numerator, and the denominator is a minus c. So yeah, don't be tempted to cancel anything here. Even though they're factors on top, you're subtracting on the bottom. So they're not factors on the bottom. Nothing cancels here. But this is our final answer, right? We solve for b. B is essentially just a times c over a minus c. A minus c. Okay. And we're done. Right? And in fact, well, I mean, you could try to check by plugging this back in, but that's more of a pain than is really necessary here. This should be the answer. So, right, so this goes under the heading of sometimes what are called literal equations, equations with, many letters. I can't spell literal. Let me try that again. Literal. L-I-T-E-R-A-L. So these are literal equations. But they are equations with fractions, and you can basically solve them the same way. Right, and in fact, I think this is one of the more difficult ones. I mean, maybe we'll do one more, just to make sure you get the hang of it. I'll do, I think, a slightly easier one than this. Okay, last one, I promise. We want to solve this equation for r. We have p equals r minus c over n. And, well, let's just copy it down. So p equals r minus c over n, right? So what do we want? We want to solve for this variable here, this r here, right? All right. Well, notice that this is an equation. This is a rational equation because it contains fractions. And in fact, both sides are fractions. If you think the p is not a fraction, well, think again, right? This is the same thing as p over 1 equals r minus c over n. So, right, so there's nothing to factor here, right? And the only restricted value is n equals 0 because that's the only denominator. So what's the LCD? The LCD, we only have two denominators, the 1 and the n, so 1 times n. 1 times n, or just n. Right. So that's the LCD. All right. So now, on to step 3, multiply both sides by the LCD. So multiply the left side and the right side, right, by n, because that's our LCD. So multiply by n on the left and n on the right, right? Remember, not top and bottom, left and right. Right? When you're solving equations, we're doing left side and right side. Okay, so what are we left with? On the left side, we have p times n over 1. And on the right, we have r minus c in parentheses. Don't forget the parentheses, right? times n divided by n times 1, which is n. Well, that's good news, because n divided by n is 1. We can cancel the common factor of n here, right? All right. So what are we left with now? We have p times n on the left and r minus c on the right. Well, remember we're solving for r, so if it's all the same to you, I'm going to just switch these two sides. I'm going to put r minus c on the left and p times n on the right. So the only way to isolate the r here is to do the opposite of subtracting c. The opposite of subtracting c is to add c. Right? Well, I should have done it here, right? Plus c here. Right? So either way, negative c plus c is 0. And so the left side is just r, because this just adds up to 0. And the right side is p times n plus c. And we're done. That's the answer. There's a lot of ways you can write this, right? You can write this as n times p plus c. You can write it as c plus n times p. You can write it as c plus p times n. Of course, I'm not picky about any of these. These are all correct. It doesn't matter which way you write it. But that's it. We solve for r, and that's all we had to do here, right? So like I say, this I think is a little bit more of a reasonable one than the one we did earlier. But that should do it, right? So that's solving rational equations. And I know it's not easy. It takes a lot of practice. So, do all the problems on Connect Math, and I think you should be okay.